Hello everyone. In the previous session I have explained the concept of conditional probability and I have solved a few problems where we are using the formula directly. So in this session let me continue the problems, but it is a logical problems or wording problems. So here is the first problem. So 10 cards numbered from 1 to 10 are placed in a box, mixed up thoroughly, and the one card is randomly picked. If it is known that the number on the drawn card is more than 3, what is the probability that it is an even number? So as I already told you, conditional probability we are going to define like probability of event A with respect to B is equal to probability of A intersection B divided by probability of B. Right, that is probability of any event A with reference to one more event which is already happened. See here you have two events. One event is a number of card drawn is even, right, and another event is probability of a card which is already drawn whose number is more than 3. Here two events are happening. One event is when a card is picked, a card is having the number more than 3. Another event is we have to pick a card whose number is even. Fine, that is we have to find, that is unknown event is even number. The number on a card which is drawn is even. Known event is which is already known that a card is when a card is picked, a number is more than 3. So here we have a two events. So let me write the event. Let us consider a event A. Let me consider event A as the number on a card, number on the card is a number on a card which is drawn from the box is even. So this is the first event. Let me take the second event, event B. Event B is number on the card drawn is more than 3. Right, so here we have two events. First one is card, when we are going to draw a card whose number is more than 3, then we have to find the probability of a card when we draw it whose number should be even. So I have taken that as A. Here we have to find the probability of unknown event A with reference to B. Now let me write the sample space. Sample space is denoted by S. Sample space in the sense all the possible outcomes, all the possible outputs. So here the cards are numbered from 1 to 10. So either it should be start with 1, R2, R3, I mean the card number will be in between 1 to 10, right? So sample space will be consisting of all the outputs right from 1 to 10. So this is what the sample space is. Fine. Now let me find out the probability of an event A. First let me write the set A. Set A is none other than the number on the card which is drawn from the box is even. So these cards are there in the box. So what are the probability of getting even number? It is 2, 4, 6, 8, 10. So how many are there? 1, 2, 3, 4, 5. 5 number of cards are even. Therefore probability of A is 5 divided by how many, total how many cards are there? 10. Fine. Now let me write down the event B. Number on the card drawn is more than 10, more than 3. More than 3 in the sense 4 is more than 3, 5, 6, 7, 8, 9, 10. So these numbers are more than 3. How many numbers? 1, 2, 3, 4, 5, 6, 7 numbers. Therefore probability of B is 7 divided by 10. Clear? So I'll just repeat once again. I have considered two events. I have written sample space which consists of all the possible outputs. Next what I have done is I have defined event A such a way that number on the card which is drawn from the box is even. So I have written all the even number cards from the total cards. So total cards are 10, even number are 5. So 5 divided by 10 is the probability of A. Similarly, event B is more than 3. More than 3 numbers in the set is right from 4 to 10. I have written here. I have find out the probability of B. Now let me calculate A intersection B as we required it to calculate the probability. A intersection B in the sense intersection is nothing but you have to write the common numbers. Common element is 4 and 6 and 8. So only 3 and the 10 is also there. So only 4 numbers are there. Fine. So this implies I can write probability of A intersection B. A, how many numbers are there? 1, 2, 3, 4. 4 numbers out of Total cards are 10. Clear? Therefore, let me write the probability of A with reference to B as probability of A intersection B divided by probability of B. So probability of A intersection B is 4 divided by 10 divided by probability of B is 7 divided by 10. So if you simplify 4 divided by 10 into 10 divided by 7, so you will get 4 by 7. So this is the required probability of event A with reference to B. Event A is none other than number on the card drawn, which is from a box is even. So even number of cards is 4 by 7. So required answer is 4 by 7. Hope so it is clear. Here is the next problem. Actually, I thought of to take this as a first problem. Anyhow, not a problem. After that concept, that is conditional probability, you just put a heading: logical problems and probability and conditional probability. So it contains both the concept. So first problem, or else if you are written that problem, not a problem, leave it. You put it as second problem. Find the probability of a 4 turning up at least once in 2 tosses of a pair of die. In the sense, if you're going to throw a die which consists of numbers from 1 to 6, as you already know. So if you're going to throw a die, you have to find the probability of how many times 4 will come upwards. So die will consist of all the 6 numbers. If you put a die, how many times 4 will come upside? So you have to find the probability of that. Fine. So let me write here. First, let me write the sample space. Sample space in the sense all the possible outputs. So when you throw a die, sample space consists of numbers from 1 to 6, right? So it is 1, 2, 3, 4, 5, 6. So only possibility is you will get any one number among 1 to 6. Right? So let us consider event A as 4 on first toss. Why? Because we are tossing it 2 times, 2 tosses, right? So 4 on first toss. And let me consider event B as 4 on second toss. This may be the cases. We have to find here, nothing as mentioned. We have to find probability of 4 turning up at least 1 in 2 tosses. That is, we have 2 events here, for that is for the first toss and the second toss. So in the first event, what I have considered is 4 on first toss. In the second event, 4 on second toss. Right? So if you're going to throw a die, when how many times? 1 time, right? For the first time, first toss in the sense you are throwing a die 1 time. So when you're going to throw a die 1 time, total how many possibilities are there? I'll just write a probability of A here. Total possibility is any number out of 6. So it is 6. Total number is 6. How many times 4 you will get? Among 6 numbers, only 1 time. When you toss a die 1 time, 4 will come only 1 time, right? So you will get 1 by 6 here. Similarly, probability of B is none other than 1 by 6. Why? Because for the second time also, when you throw, total 6 numbers are there. Among 6 numbers, you should get 4 only 1 time, right? So that is the probability of 1. That is the probability of getting 4 1 time. So 1 by 6 and 1 by 6. Then A union B. In the sense, either you will get a 4 on upside in the first toss, or else you will get a 4 on upside on the second toss. So either in the sense, either you will get 4 in one toss, or you will get it in second toss. So you have to find probability of A union B. Total you are going to finding. So I'll just write here A union B in the sense event 4 on first toss or 4 on second toss, which is none other than event at least 1 4 upside, right? Event, getting an event, I'll just write here, getting event at least 1 4 upside, right? We have to find probability of A union B now. It gives how many total number of times when 4 comes upside. So probability of A union B, you already know the formula for it. So probability of A plus probability of B minus probability of A intersection B. Right? And moreover, here P of probability of A intersection B is not known. Only data we know is probability of A and probability of B. So we need to express probability of A intersection B in terms of probability of A and probability of B. Since A and B are independent event, you can see that event A is independent. Why? Because we are event A, what we have assumed is getting 4 on first task. Similarly, event B is 4 on second task. So first task is having no connection with the second task, so they are independent event. So as I already told you, whenever we have two independent events, that is, I'll just write it as note point. If A and B are independent events, then what we can write? Probability of A intersection B as probability of A into probability of B, right? I'll just replace this with in the above equation. So I can write probability of A union B as probability of A plus probability of B minus probability of A into probability of B. Now you can note that all the values are known to us. So let me substitute. You will get 1 by 6 plus 1 by 6 minus 1 by 6 into 1 by 6. So I'll just take LCM. So you will get 2 by 6 minus 1 divided by 6. 6 are 36. So LCM for 6 and 36 is again it is 36. So let me do that. If you're going to take LCM, you will get 12 minus 1 here. Fine, 36 you multiply. So 6 2s are 12. 12 minus 1. So it is 11 by 36. Therefore, probability of A union B is equal to 11 by 36. So this gives the total number of times that 4 turning up at least once in a 2 tosses. This is the total probability of 4 turning upside when we toss a die twice. Fine, that is what we have to find. See here, A consists of 4 comes upside when we toss it first time. So B consists of an event 4 comes upside when we toss it second time. Fine. So both in both the trial we have to find how many times it comes. So it will come at least of 11 by 36 times. Next problem. So a family has 2 children. What is the conditional probability that both the children are boys given at least one of them is a boy? So in the exam they will not mention the concept, that is whether it is based on the probability or conditional probability. You have to identify. In case of conditional probability, 2 events will be given. One event is current event and the another event will be already occurred. So here a family has 2 children. What is the conditional probability that both the children are boys given at least one of them is a boy? So we have to find the conditional probability. First, before solving this problem, let me write the sample space. In the sense, what are the possibilities? See here, a family has 2 children. So either they may be boy or they may be girl, right? So conditional probability that both the children are boy given at least one of them is boy. So family has 2 children, either it should be girl or boy. So possibilities are either they will be something like this, right? Boy girl, boy girl. Either they will be girl or boy, or they will be girl and girl, or both the children will be boy and boy, and both the children will be boy and girl. Possibilities are, see here, family has 2 children. Those 2 children will be either girl or boy, or both are girls, or both are boys, or one is boy and another is girl. So this is the required sample space, right? Let me consider an event A as both are boys. See here, conditional probability that both the children are boys. We have to find conditional probability that both the children are boys. So I am taking A as event of both are boys. So both are boys in the sense, what are the possibilities in this sample space? Only B and B, right? Both are boys. So how many numbers is there? 1 out of 4, right? So total possibilities are have listed in sample space, whereas condition for both the boys are only one case, right? So let me take an event B as children are boys given that at least one of them is boy. Second event is given here, at least one of them is boy. So let me take second event as at least one boy. Remember in one boy. Remember in conditional probability always two what we say, events will be given. So in this problem also 2 events are given. First event I have chosen it as both are children are boys. Second event is one of them is a boy, so I have taken second event. So if that was the case, what is the possibility that at least one is a boy? So it is girl boy, or else at least one is boy, in the sense either it may be boy and boy or boy and girl, right? So this is the only way of getting at least one boy. One boy in the sense another should be girl, one boy in the sense another may be boy, and boy and girl, right? Now we have to find probability of event A with respect to B, right? That is probability of both are boys when at least one is a boy, right? So this is what we have to find as. So let me write down the formula, that is conditional probability of A with respect to B is probability of A intersection B divided by probability of B. Now first we have to find probability of A intersection B. Before that, let me find A intersection B. A intersection in B in the sense common element between set A and set B. Clearly common element is BB, right? Now let me find probability of A intersection B. Probability of A intersection B in the sense how many event A intersection B has? Only one event. Both the children are boy is one event here. Girl and boy is one event. Boy and girl is one event. So they are all single events. So boy and boy is one event. Out of sample space, how many events are there? 4 events. Fine. So probability of A intersection B is 1 out of 4. So there is one chance out of 4. Now let me find probability of B. So probability of B in the sense how many elements are there in B? 1, 2, 3 out of 4 chances. So these 3 chances may be there out of 4 chances. So it is 3 by 4. Clear? Now let me substitute. So probability of A with respect to B is probability of A intersection B is 1 by 4 divided by 3 by 4. So you will get 1 by 4 into 4 by 3. So it is 1 by 3. Therefore probability of event A with respect to B is 1 by 3. Clear? That is probability of getting both are children are boy when at least one of them is boy is 1 by 3. I am just repeating once again. First you have to write down the sample space. After that take 2 events given and list out the element which is possible from the sample space. Fine. Next what we have to find is probability of A with reference to B. Write down the formula and calculate from the obtained data. Hope so it is clear. So here is the next question. A die is thrown twice. As you already know, in a die how many numbers are there? Right from 1 to 6. So a die is thrown twice and the sum of the numbers appearing is observed to be 6. What is the conditional probability that the numbers 4 has appeared at least once? Fine. So when a die is thrown, as I already told you, so numbers in die is from 1, 2, 3, 4, 5, 6. So when you throw it first time, you will get 1 here. Fine, whatever the number I am going to write here in the first place, it is representing first throw. Second number representing second throw. So let me write this as 1 1, 1 2, 1 3, 1 4, 1 5 and 1 6. Clear? Similarly, first throw 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. I am just writing the possibility. Similarly, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. Similarly, first die 4 1, second throw 4 2. First throw 4, second die 1. First die 4, second die 2. Second throw 2. So similarly 4 4, 4 5, 4 6. Similarly 5 1, 5 2, 5 3, 5 4, 5 5. 5 6. Similarly 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So these are the only possibilities that you're going to get when you toss a die 2 times. So this will be the number on first die and this will be the number on second die. Now how many possibilities are there? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36. Remember, when a die is thrown twice, you will get 36 possibility. That is, sample space contain how many number of element in a sample space? Yes, is 36, as I already listed. This is only for your reference. Fine. So this is the actual problem we have. Now, what they have asked is, sum of the number appearing is observed to be 6, in the sense, when you add these two numbers, you should get 6. So, let me write that as event A. Event A as sum of number appearing is 6. So, what are the possibilities? Check here. 1, it cannot be 6. So, 1 plus 5. See here, 1, 5 will be 6. So, I'll just write here 1, 5. Next possibility is 2, 4. 4 plus 2 is 6. Similarly, 3 plus 3 is 6. Similarly, 3 plus 4. 3 plus 4 is 7. Right? So, we cannot choose it. So, we cannot take 3, 4. Next is 4, 2. 4 plus 2 is 6. Next is 5, 1. Right? Apart from these 5 possibilities, you cannot get 6 when you add two numbers. See here, 6 plus 2 will never give 6. 5 plus 4 will never give 6. 4 plus 5 will never give 6. So only these 5 numbers, with these 5 possibilities, when you add two numbers, you will get 6. So that is the event A, that sum of the numbers appearing is 6. So when you add these two numbers, you will get 6. So this is the event A. Let me take second event B as, next what is the given, what is the conditional probability that the number 4 has appeared at least once, in the sense, in these two chances, at least 4 should be there once. So what is the chances? It is 1, 4. That is, I'll just write here, the number 4 appearing at least once. At least once. So what are the cases? It should be either 1, 4. See here, 4 is appearing at least once. Next is 2, 4. Here also 4 is appearing at least once. Next is 3, 4. Similarly, 4, 4. 4, 4 in the sense at least once it is appearing. No, so you have to consider that also. Next 4, 1. 4, 2. 4, 3. 4, 4. Already written. It is 4, 5. 4, 6. 5, 4. 6, 4. Right? So in all these cases, you can observe that 4 is appearing at least once. Fine. Now let me make a list of A intersection B. I'll just make a list of common element. So which is the common element? 2, 4 and 2, 4. And next is 4, 2 and 4, 2. Right? So I have listed the common element in set A and set B. I have obtained A intersection B. Now let me find probability of A intersection B. Why? Because anyhow we need to calculate further. So how many elements we have in A intersection B? It is 2 out of 36 possibility. That is, sample space is totally consisting of 36 possibility. So out of that we have only 2 in A intersection B. So I have listed probability of A intersection B. Now, what we have to find is, what is the conditional probability that a number 4 has appeared at least once. That is, we have to find this event with reference to the event where the sum of the number appearing is observed to be 6. Fine. That is, we have to find the probability of this event. This event is none other than event B. Fine. So, we have to find the probability of event B with reference to event A. Make sure before writing that what we have to find. See here, we have to find event B, that is probability. What is the conditional probability of what this is? This is nothing but event B with reference to event A. That is, we need to find probability of event B with reference to A is given by probability of A intersection B divided by probability of A. Now anyhow we have calculated A intersection B, we need to calculate probability of A. So probability of A is given by how many elements do we have in A, set A? 1, 2, 3, 4, 5 out of 36. So it is 5 divided by 36. Now let me substitute probability of B with reference to A is A intersection B is, we have already done it. So it is 2 by 36 divided by 5 by 36. So on simplification you will get into 36 by 5. When you shift this you will get this. So probability of event B with reference to A is 2 by 5. The main thing is you need to identify which is the event that we require to find. See here, we have asked to find the probability of the number 4 appeared at least once. That is, we need to find probability of event B with reference to event A which is already occurred. So this is what the solution is. Hope so it is clear. This is the sample space, that is possibility when we throw a die which has 6 numbers. So this is when for the first throw, this is for when second throw. Fine. Hope so it is clear. Just copy down. You should write this also, sample space also. Clear? So here is the next problem. Two students, and it is a very important problem. Two students A and B work independently on problem. The probability that A will solve it is 3 by 4 and the probability of B is 2 by 3. What is the probability that problem will be solved? So first let me write the given data. So probability of A is given. A will be 3 by 4 and the probability of B is given by 2 by 3. Now what we have to find is, see here, two students A and B are work independently. It is very important as A and B are working independently. When the word independent comes, it is very important, as I already told you. So when two events A and B are independent, I have already given the property list. You should go through that. So when do we say two events are independent? When probability of A intersection B is equal to probability of A into probability of B. Clear? So here clearly given that A and B are working independently. Therefore, I can write probability of A intersection B is equal to probability of A into probability of B. Clear? Now, what we have to find is probability of A union B. Fine. I'll just repeat once again. Since the students A and B are working independently, so I have applied the condition for independent probability. Fine. Now probability of A is given and listed here and the probability of B is listed here. What is the probability that problem will be solved? Since they are solving, both the students A and B are solving the problems, so either A will solve it or B will be solving the problem. Why? Because they are working independently. So or in the sense you have to use union. So that is the reason A union B we have to calculate. Fine. We know that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. This is the formula we have, but we don't know the probability of A intersection B. So let me replace A intersection B, probability of A intersection B with this. Let me using 1. How can I write this as? Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B is probability of A into probability of B. Clear? Now we can substitute the available data. That is probability of A is 3 by 4 plus probability of B is 2 by 3 minus probability A is 3 by 4 into probability of B is 2 by 3. So 3 get cancelled, 2 1s are 2 2s are. So what you left with 3 by 4 plus 2 by 3 minus 1 by 2. Fine. Now let me take the LCM for 4, 3 and 2. So 2 2s are 4. 3 as it is, 2 1s are again, 2 1s are again, 3 1s are. So 2 2s are 4, 4 3s are 12. So 12 is the LCM. So when you take 12 is an LCM, 9 plus 8 minus 6 you will get. So it is 11 by 12. Therefore, probability of solving the problem either by A or B is 11 by 12. That is, probability that problem will be solved is 11 by 12. That is, probability that the problem solved is 11 by 12. Clear? So here key point is we need to identify what we have to find and you have to make use that they are independent. So I am using the property of independent of a probability, independent property of a probability. That is, whenever two events A and B are independent, we can write probability of A intersection B as probability of A into probability of B. Clear? You just copy down this problem. So here is the next problem. A ball is drawn at random from a box containing 6 red balls, 4 white balls and 5 blue balls. Find the probability that it is red, white, not red, red or white. So just by looking at the problem we can decide it is not based on the conditional probability. Why? Because we have discussing only with reference to one event, single event. So this is a problem on probability but not on conditional probability. That is the reason I have mixed all the problems, logical wording problems. So while solving the problems you should be able to identify whether it is conditional probability or only probability. So clearly this is problem based on probability. First let me write down the given data. A ball is drawn at random from a box containing 6 red balls. Fine. So red balls is 6. Again white balls is, number of white balls is 4, and 5 blue balls. So blue balls is given, it is 5. Total number of balls, let me find out. Total balls will be 6 plus 4 plus 5. So it is 15. Fine. Now what we have to find is probability of getting a red ball. So first let's write on the formula, that is number of favorable outcomes. Number of favorable outcomes divided by total number of outcomes. Right. So favorable in the sense, how many red balls are there? 6. Out of how many balls? 15 balls. That's all. Very simple. See, is probability of getting red ball is none other than total number of favorable by total number of outcomes. Total number of number of favorable divided by total number of outcomes. Total number of balls is none other than 15. Out of 15, how many red balls are there? 6 balls. So we can choose only 6 times a red ball. Fine. Second one, white ball. Similarly, white ball in the sense, you have to write the formula. You just copy down the same formula. So probability of getting white ball is, how many white balls are there? 4. Out of how many balls? 15. So probability of getting white ball is 4 by 15. Probability of getting red ball is 6 by 15. Clear? Now let me solve third one. It is not red. Probability of not red. Not red in the sense, let me take red as R. So if event R is getting red, R bar represents not red. Complement of an event. If R represent a red ball, then complement, that is R bar represents a ball which is not red, right? So I have already given a relation connecting event and its complement. We know that probability of R bar is equal to 1 minus probability of R. Why? Because we have already calculated probability of red ball. So let me take this as probability of R. Clear? What I have taken is red ball as R. So since not red in the sense, it is not red, R bar represents not red, R represents red, right? So probability of R bar will be 1 minus probability of R. We have already calculated, it is 6 by 15. Just take an LCM. So you will get probability of R bar is equal to 15 minus 6 divided by 15. So after simplification, you will get probability of not red is 9 divided by 15. So this is the solution for third one. Clear? Next, look at the fourth one. What we have, I'll just do it here. So fourth one is red or white. R. So probability of red, R in the sense, I have already told you, union white is question mark. Clear? Red, R in the sense union white. So you know the formula, probability of R union W is probability of R plus probability of W minus probability of R intersection W. I have already given this formula. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. There I have replaced A and B with R and W. Fine. First let me find R intersection W. R intersection W in the sense, do we have any common ball between red ball and white ball? Red ball is separate and white ball is separate. We don't have any common ball. So it is 0. So probability of R intersection W will be 0. So this term will not be there. Now let me calculate probability of R union W, which is equal to probability of red is 6 by 15. I have already calculated here probability of red ball. Next, probability of W in the sense white ball. Probability of W in the sense probability of white ball, that is 4 by 15 minus probability of red intersection is 0. Fine. Now let me simplify this. Probability of R union in the sense R white ball will be equal to 15 as an LCM. So we will get 6 plus 4, it is 10. Therefore probability of red or white ball will be equal to 2 by 3. That's all. Clear? Since it is only with reference to single event, so it is a problem based on only probability but not conditional probability. So I have solved this just by using this formula. So this is from the property of probabilities, that is P of A union B is equal to P of A plus P of B minus P of A intersection B. So instead of A and B I have replaced R and W. So rest of the thing is same. Whatever I have calculated, I have taken probability of red as P of R, probability white as P of W, and this is a relation between event and its complement. So I have used this. Why? Because they have asked it as not red. Not red in the sense getting red is event. Not red in the sense it is complement. So I have used the relation. Hope so it is clear. Fine. Here is the next problem. Again it is an important problem. So 2 cards are drawn from a well shuffled ordinary deck of 52 cards. Anyhow I have given a list of cards. You just go through that. So find the probability that they are both ace if the first card is replaced and second one is not replaced. So this is also based on probability only. Why? Because only a single event is given, right? In the sense what the condition is given is, see here 2 cards are drawn from a well shuffled ordinary deck of 52 cards. Find the probability that they are both ace. Oh, here 2 conditions are given. See here that they are both ace cards if the first card is replaced, and second one is if the card is not replaced. So 2 events are given here. I'll just list down the events here. See here, let us take event A as event ace card on first draw, right? So 2 cards are drawn. So when first card is drawn, getting an ace card. So when second event is ace on second card, second run. Fine. It is we can solve this either by using the conditional probability or usual probability. See here, why? Because in the both the drawn of a card, when you draw 2 cards from a deck of 52 cards, both are ace cards. We have to find probability that they are both ace cards. So whatever the 2 cards that you're going to pick from a 52 cards, both cards should be ace cards. See here, event A is ace card on first run, and event B is also ace on second run. So when you're going to draw it second time, then also it should be ace card. Then we have to find when it is replaced what is the probability, when it is not replaced what is the probability. That is, we have to find both, common, in the sense when you're going to get a when you're going to draw a card from a pack of cards, in both the events you should get an ace card. So that is what we have to find this. Fine. First, when you're going to draw it for the first time, how many ace cards are there? Ace card in the sense a card which is of number 1. So instead of number 1, they'll call it as ace card. So in a deck of cards, I have already told you, you have clubs, spades, diamonds and hearts. So you have 4 cards, each of 13 cards. So in each set, you will have 1 ace cards. Fine. 1 ace cards you have. Totally how many ace cards are there? 4 ace cards are there out of 52 cards. So we can clearly say that probability of getting an ace card in a first event is, how many cards are there? 52 cards total. So in out of 52 cards, how many ace cards are there? 4 ace cards are there. So 4 ace cards can be drawn out of 52 cards. Fine. Similarly, if you're this is for the first case, that is when a card is replaced. I'll just write here, when a card is, I'm going to solve it for the first one. When a card is replaced, in the sense after 4 cards, what I'm going to do is, when I'm going to take 1 card and I'm going to place it again. Replaced meaning is that's all. So I'm going to place it again. Either you can shuffle this or you can keep as it is. When you're going to replace the card, how many cards are there? Again you'll be having the same number of cards, right? Why? Because you're replacing it. You're again keeping it back. Not replaced in the sense you are not keeping it back. Fine. So since you are replacing the card, you are keeping the card again. So when a card is replaced, then also there are 4 ace cards out of 52 cards. Therefore, probability of getting an event B is 4 ace cards out of 52 cards. Therefore, probability of B will be equal to 4 ace cards. In the second draw also, you will be getting 4 by 52 only. Why? Because you are replacing it. You are keeping it back again. Fine. Now let me find probability of A intersection B. So since A and B are independent event, so we can write why, because they are not depends one another. So in order to find A intersection B, we can write probability of A into probability of B. Just now I have told you, whenever there are two events which are independent, we can write probability of A intersection B as probability of A into probability of B. So what is the value of probability of A? 4 by 52. Probability of B is also 4 by 52. So when you simplify, you will get 16 divided by it is 2504. So after simplification, you will get 1 divided by 169. The probability of A intersection B will be 1 divided by 169. This is when we replace the card. Again, if you keep back the card. Second case, when you are not replacing it, when a card is not replaced. So when you're not replacing the card, we have to find the probability. Whatever we have done, we have to repeat the same procedure. Fine. So when you're not replacing, when you draw it first time, I'll just repeat it. I'll give you a glance so that you'll understand well. See here, what we have is total 52 cards. Among 4 ace cards are there. You have to draw twice. When you're going to draw it for the first time, you should get an ace card. When you're going to draw it for the second time, then also you should get a ace card when we replace the card. So when you're not, when you're going to draw it for the first time, you're getting an ace card, right? So that will be, there are totally 4 ace cards there. So one card will be there among 4. So it is 452. 4 divided by total number of cards is 52, right? Now what we are doing is, when a card is not replacing, so in the first draw what you're going to get, and in the second draw what you're going to get. Why? Because we are drawing the card for 2 times. Clear? So when a card is not replaced, we have to solve whatever we have done in first case, we have to repeat the same. Fine. So when you're going to draw it for the first time, for the first draw, there are initially there are 4 ace cards out of 52. Therefore probability of A will be 4 by 52, right? If card is not replaced, this is for second one. You should not write this statement, then only you will understand well. See here, for the first draw there are 4 cards. Initially there are 4 cards out of 52 cards, so you are drawing one ace card from 52 card. So if card is not replaced, in the sense, if you are going to draw one card from this, and again you are not keeping back it, so how many cards will be there? If you are going to take this out and you are not keeping it back, so there will be 51 cards. How many ace cards are there? 3 ace cards, right? When you are not replacing it, when you are going to pick this card, again you are not keeping back, so totally 51 cards are there among 3 ace cards, right? So when you are not replaced it, I can write there are 3 ace cards out of 51 cards. Therefore here probability of B will be 3 ace cards among 51. Fine. Therefore I can calculate probability of A intersection B as probability of A into probability of B. What is the value of probability of A? 4 by 52 into probability of B is 3 by 51. So when you simplify this, you will get 4 into 3 is 12 divided by 2652. So after simplification, you will get 1 divided by 221. 1 divided by 221. I'll just repeat it once again. So there are 52 cards among 4 ace cards. So I have taken A in the both the drawn also. You should be getting ace card as per the given problem. We have to find the common ace card in both the draws, that is A intersection B. So first initially we have to find probability of event A, right? So there are totally 4 ace cards are there. So this is the initial condition, initial probability case. So what we are doing is, card is replaced. So if you are going to take it one card, again you are keeping back it, so there will be no change in the probability of getting S cards, so you will get 4 by 52 only. Whereas in the second card, initially there will be 4 S cards. What you are going to do is you are picking one S card, but you are not keeping it back. So when you pick one card, after 52, one will be reducing. That is 51 total card, and 3 Ace cards will be there. Therefore, probability will reduce it to 3 by 51. So multiply and substitute in a formula. You will get 1 divided by 221. I understand the problems are quite abstract. More the problems you practice, more perfect you will become. So you just practice it. If you have any queries, you can free to ask me. Here is the next problem. A bag contains 30 bats numbered from 1 to 30. In the sense, our sample space will be containing a numbers from 1 to 30. One bat is drawn at random. Find the probability that the number of bat drawn will be multiple of 5 or 7, 3 or 7. R is given, so you have to find union. So let me take A as multiple of 5. I'll just write multiple of 5 here. Write from 1 to 30. How many multiples of 5 is there? 5 ones are, 5 twos are, 5 threes are 15, 20, 25, 30. So stop at 30. Why? Because we have only numbers up to 30. Next, let me take B as multiple of 7. Multiple of 7. So write down multiple of 7. 7 ones are, 7 twos are. Right here. Why? Because you have up to number 30. So these are multiple of 7. Now I am going to solve first one. 5 or 7, right? So we have to find probability of A, that is multiple of 5, R in the sense union, B. I'll just write one more statement, R, B. That is probability of A union B we have to calculate. So what is the formula? Probability of A plus probability of B minus probability of A intersection B. Clear? So first let me write down probability of A. Probability of A in the sense, how many numbers are there? 1, 2, 3, 4, 5, 6. Out of how many numbers? 30 numbers. So it is 6 by 30. Probability of A is, probability of A is 6 by 30. So probability of B is, how many numbers are there in B? 1, 2, 3, 4. Out of 30 numbers. So it is 4 by 30. Now we have to find A intersection B. So do we have any common element between A and B? Clearly there is no common element. So probability of A intersection B is, so there is no common element. So probability of A intersection B will be 0. Fine. So let me substitute. Therefore probability of A union B will be, probability of A is 6 by 30 plus probability of B is 4 by 30. You should not put set symbol here. Why? Because 0 is also element. So there is no common element between A and B. So minus probability of A intersection B is 0. Therefore probability of A union B is equal to, so let me simplify this. So what is the LCM? 30. You will get 6 plus 4 here, 10 by 30. So 10 ones are, 10 threes are. Therefore probability of A union B is 1 by 3. Fine. That is probability of 5 or 7. A or B. 5 or 7. I'll just write here. Probability of A is multiple of 5 or B is multiple of 7. Fine. So now similarly let me solve the second one. Probability of multiple of 3, here clearly given, multiple of 3 or multiple of 7. We have to find that is, let me take A as multiple of 3. Multiple of 3, right from 1 to 30 is 3 ones are, 3 twos are 6, 9, 12, 15, 18, 21, 24. But so we cannot go apart from this. Why? Because we have only numbers up to 30. So let me take B as multiple of 7. It is 7, 14, 21, 28. Do we have any common element? Why? Because we need A intersection in the formula. So A intersection B is, yes, we have a common element. So let me make a list of common elements here. A intersection B is 21 is there. Do we have extra element here? No, we don't have. So only one element is there. Therefore, let me write probability of A intersection B. How many element is there in A intersection B? It is only one element. You should not write the number. Only element you have to count. One number out of how many numbers are there? Sample space 30 numbers. So 1 by 30. Similarly, you can write probability of A and B. So I'll just calculate probability of A and B. Probability of A in the sense how many numbers are there in A? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 30 numbers. Why? Because in the sample space we have 30 number. Similarly, probability of B is 1, 2, 3, 4 out of 30 number. Now we need to calculate A or B in the sense union B. Probability of A plus probability of B minus probability of A intersection B. This is the formula. Now what is the probability of A? 10 by 30. Probability of B is 4 by 30 minus probability of A intersection B is 1 by 30. So 30 is a common factor. LCM. So we'll get 30 plus 4 minus 1. 10 plus 4 is 14. 14 minus 1 is 13. So probability of A or B, that is probability of multiple of 3 or multiple of 7 is 13 by 30. Hence the solution. This is for first sub question and this is for second sub question, and that is what we need to find is probability of 5 or 7. So probability of multiple of 5 or 7 is 1 by 3. Multiple of 3 or 7 is 13 by 30. Hope so it is clear. So here is one more question and it is important. This problem is quite different compared to previous one. So a die is thrown. If A is an event, what is the A is event given? The number appearing is multiple of 3. And B is an event that the number appearing is even. Then find whether A and B are independent. So as I already told you, whenever we say two events are independent, so I'll just write here two events A, and we know that two events A and B are independent only when probability of A intersection B is equal to probability of A into probability of B. I have already told you this a number of times. So if it satisfies this condition, two events A and B satisfies this condition, we can say A and B are independent events. So we have to prove two events are given. Let me make a list. Event A, what is the event A is given? The number appearing is multiple of 3. That is, the number is multiple of 3. Right? So next, when it is die is thrown, when a die is thrown, what is the first? Let me write the event. Next event B is, what is the event B is given? The number appear is even. The number is even. So first let me write the sample space. Sample space in the sense all the possible outputs. So when a die is thrown, what is the sample space? What is the possibilities? Either you should get any one of this number, right? So now let me write event A. So event A in the sense number is multiple of 3. Which are the number multiple of 3? Only 3 and 6. So event B is number is even, right? Even numbers among this is 2, 4 and 6. So these are even numbers, right? Now we have to find these terms. First let me write LHS. LHS in the sense probability of A intersection B. So first let me write A intersection B. A intersection B is none other than, it is common term. Do we have? Yes, we have. So probability of A intersection B, I'll just find here. A intersection B is 6. Among how many events? First you just write down the formula. Number of favorable outcomes divided by total number of outcomes, right? So favorable outcome in the sense how many numbers are there in A intersection B? 6. Total number, how many possibilities are there in total number of sample space? Total number will be always from sample space only. So 1, 2, 3, 4, 5, 6. Fine. So how many elements are there? Here most of the students will make mistake. It is number of favorable outcomes. So how many number is there? Only one number. It is not a 6. You have to count the number. You should not write the element. So it is 1 by 6. So this is the probability of A intersection B. Let me take this as equation 1. Now let me find probability of A. So in set A, how many elements are there? 1, 2. Out of 6 element. So 2 1s are 2 3s are. So it is 1 by 3. Next let me find out, I'll just simplifying RHS here. RHS and LHS of equation. Let me take this as 1. From equation 1 I have considered LHS. From 1 I have considered RHS. Probability of A I have done. So to find probability of B, how many elements are there in B? 1, 2, 3. Out of sample space is 1, 2, 3, 6. So 3 ones are 3 twos are. It is 1 by 2. Now let me calculate P of A into P of B. P of A into P of B, it is 1 by 3 into 1 by 2. So we will get 3 twos are 6. Now let me take this as 3. Now compare equations 2 and 3. From equations 2 and 3, probability of A intersection B is equal to, why? Because RHS are equal. So probability of A intersection B is equal to probability of A into probability of B. Therefore it's satisfying the condition of independent event. Therefore I can write, therefore A and B are independent events. Clear? So whenever two events are given and they asked you to prove whether they are independent or events or not, so we have to verify this condition. If it satisfies this condition, we can say they are independent event. So if not, they are not. Now I'll give you same kind of problem. See here, an unbased die is thrown twice. Let the event A is odd number on the first throw and B is event odd on the second throw. Fine. Find whether A and B are independent. So as I already told you, whenever they are asked you to find whether they are independent or not, we have to use this condition. So I'll give you a key point. Whenever a die is thrown, see here, when die is thrown, you will get only 6 in a sample space. Fine. So when die is thrown twice, you will get 36. You just write it a note point. Fine. So when die is thrown once, then number of sample space will be only 6. That is right from 1 to 6 you will get. Fine. So second key point is when die is thrown twice, then number of sample space will be 36. So as I already solved it in one of the problem. So in this problem I have solved. So these are the 36 chances when we throw it twice. So remember, when we throw it twice you will get 36 chances. When it is once you will get only 6 chances, that is 1 to 6. Fine. So here unbiased die is thrown twice. So you are going to get 36 sample space. That is number of elements in a sample space is 36. So let me write event A. Fine. So event A is, let the event A is odd number on the first throw. Odd number on first throw. Fine. And B, event B is also given. Event B is odd number on second throw. Fine. So for that, first we have to find what are the possibilities in event A. That is odd number in A. So again I cannot write all those chances, so I'll just refer this. Anyhow I have solved this in one of the problem, that is a die thrown twice. You just refer the problem where I have given a list of all the 36 possibilities. Now I have to list a event A such that odd number on the first throw. Odd number on the first throw in the sense, as I already told you, a first position number represents a number for a first throw. Second position number represents for a second throw. Now we have to find odd number on the first throw, in the sense in the first position number should be odd number. So I will just make a list of all those. Odd number on the first row is, so 1 is an odd number, so we'll get 1, 1. Again 1 is odd number, so 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So in all the first places you have 1, so 1 is an odd number. Fine. So in the next position is 2, 1. 2 cannot be odd number, so I cannot write 2 here. Next 3. Again 3 is an odd number, so I can write 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Why? Because in the first position all the numbers are odd. 3 is an odd number. First position number should be odd. Fine. Next 4 cannot be odd, 6 cannot be odd, so 5 will be odd number. So 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. So these are the only possibility when we throw a die that we get odd number in the first chance, that is first throw. So how many I'll just find probability of A here only. So how many numbers are there in A? So you have to remember that since you are throwing a die twice, so this entire set will be considered as single element. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 numbers are there out of sample space consisting of 36, out of 36. So it is 1s are 2s are. So probability of A is equal to 1 by 2. Let me similarly write a set containing B. B in the sense odd number should be there in second throw. In the sense second element should be there, should be odd number. No matter whatever may be the first number, second number should be odd number. So clearly 1, 1. For second number is odd number. Next 1, 2. Second number is not an odd number, it is even number. Next 1, 3. Yes, it is an odd number in the second chance. 4 cannot be odd. Again 1, 5 is an odd. Next 1, 6. 6 cannot be odd. Why? Because you have to look at the second throw. Second throw should be odd number. Again 2, 1. So 1 is in the second place. You have to write 2, 1. Clear? Next 2, 2. 2 cannot be odd number. Again 2, 3. Yes, it is an odd number in the second throw. Next 2, 4. 4 is not odd number. Again 2, 5. So 5 is an odd number. You have to look at only second position number. Next 2, 6. 6 cannot be odd. Next 3, 1. Yes, 1 is an odd. Next 3, 2. 2 cannot be odd. Again 3, 3. Yes, it is an odd. 4 cannot be odd. Again 5. 3, 5. So 6 cannot be odd. Next 4, 1. Yes, 1 is an odd number. Next 2 cannot be odd. Again 4, 3 is an odd number. Again 4 cannot be odd. Again 4, 5 is an odd number. 6 cannot be odd. Next 5, 1. Again 2 cannot be odd. 5, 3. Again 4 cannot be odd. Again 5, 5. Again 6 cannot be odd. Again 6, 1. Because 1 is an odd number. 6, 2. 2 is not an odd number. Again 3 is an odd number. So 6, 3. 4 is not an odd number. So 6, 5 is an odd number. Again 6 is not an odd number. So these are the chances of getting an odd number in the second throw. So these numbers represents odd number in the second throw. So only these numbers. Fine. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So again probability of B will be 18 numbers out of total sample space 36. So probability of B, again it is 1 by 2. So I have calculated probability of A and probability of B. So when do we say two events are independent event? Only when it satisfies probability of A. I have already given this in the previous problem also. You just cross check it if you want. So probability of A intersection B will be probability of A into probability of B. That should satisfy this condition when they are independent. So first let me write A intersection B. In the sense, do we have any common element between these two? Yes, we have. So let me make a list. 1, 1 is there. Again 3, 3 is there. And again 5, 5 is there. And 1, 3 is there. Again 1, 5 is there. 3, 1 is there. 3, 5 is there. 5, 1 is there. Again 5, 3 is there. So I have listed common element between A and B. So let me find probability of A intersection B. So probability of A intersection B is how many numbers are there common? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers out of 36. Clear? So 9 ones are 9 fours. It is 1 by 4. Therefore probability of A intersection B is 1 by 4. Clear? So this is the LHS value. LHS is 1. Probability of A intersection B is equal to 1 by 4. Now let us consider RHS, probability of A into probability of B. What is the value of probability of A? It is 1 by 2 into probability of B is again 1 by 2. So let me multiply 1 by 2 into 1 by 2 is 1 by 4. Therefore LHS is equal to RHS, that is probability of A intersection B is equal to probability of A into probability of B. Therefore A and B are independent. This statement should be there, very important. It carries 1 mark. A and B are independent events. This conclusion should be written. Hope so it is clear. Just the thing is you have to calculate this part LHS and RHS term you have to multiply, and you have to remember these two key points. So hope so it is clear whatever I have done in this session. You just go through this and write the same in the notes Further, if you have any doubt, I'll clarify it in next session. So in the next session, I'll be doing with the Bayes theorem. Anyhow, you have already done it in your second PU. So again, the same concept will be repeating. So in the next session, I'll be starting with Bayes theorem and the proof of the same. Thank you. Continue in the next session.